Welcome back to our website of Tech Talks, where we're exploring you more with more content as far as education is concerned. So we are still moving on with the third example, still under partial fractions, for the case where the denominator has a quadratic factor. And examples you can say express 1 all over x power 4 plus 5x squared plus 6 in partial fractions. So we want to express such a kind of a number. Now you can see that what is common here, we're going to first factorize out this one and we see if it can be factorized. Solution: x power 4 plus 5x squared plus 6 is the same as x squared, the whole of it squared, plus 5x squared plus 6. Now you can see that x squared is common. I will say let x squared equals y. So where I see x squared, I'm going to put a y. So this one is going to become y squared plus 5y plus a 6. Then we factorize out this. What is the product? Product is 6. And what is the sum? Sum is 5. We look at the factors. The factors we have got 2 and 3. Because when you say 2 times 3, you get a 6. And 2 plus 3, we are getting a 5. So we are going to substitute in that. We are going to have y squared plus 2y plus 3y, then plus 6. Then the two numbers in a bracket. So we have got y into y plus 2. Then plus, what is common here is a 3 into y plus a 2. So what am I going to write? We're going to write y plus 3 into y plus 2. But do we know the value of y? Y is already x squared. So we substitute, we are getting x squared plus 3 into x squared plus 2. So what does it imply? So we are going to say 1 all over. Instead of this, we are bringing in this x squared plus 3 into x squared plus 2. This is the same as, you can see these are quadratics which cannot be now be factorized. And what do we do with this? We're going to say this is ax plus b out of x squared plus 3 plus, still this one cannot be factorized, we say plus cx plus d out of x squared plus 2. What do? We are going to get the LCM on the right hand side. So we are having 1 all over x squared plus 3 again into x squared plus 2 is the same as the LCM, which is the same as the LCM here is the same as x squared plus 3 again into x squared plus 2. So the whole of that one divided by this, we are coming out with x squared plus 2. So we are going to have ax plus b into x squared plus 2, then plus the whole of that one we are having cx plus d, cx plus d into x squared plus 3. So what happens with the denominators? On the left hand side together on the right hand side, all of them they are the same, they are going to cross. We are going to remain with 1 is the same as ax plus b into x squared plus 2 plus cx plus d into x squared plus 3. So can we go ahead and open up these brackets? So what are we having? We are having ax cubed plus 2ax plus bx squared plus 2b. Then plus, we open up that cx times x squared, we are getting cx cubed plus 3cx plus dx squared plus 3d. Again, we go ahead, we collect like terms. Those ones with the cubed, they come close. So this is the same as ax cubed plus cx cubed. We got those ones with now x squared. We say plus bx squared, then plus dx squared. We got those ones without a squared. We are going to do 2ax plus 3cx. We got those ones without x. We say plus 2b plus 3d, which is equal to 1. Now, we go ahead and we do the factorizing out. So this is the same as 1 is the same as a plus c into x cubed plus b plus d into x squared plus we are having 2a plus 3c into x, then plus 2b plus 3d. So we are going now to use the same idea of saying equating monomials of same coefficient of same coefficients. So one start equating those ones in the left hand side together with those ones in the right hand side. So I've got a plus c equals, in this side there is nothing, we say this is the first value. We also come b plus d equals 0, this is the second. Another one is 2a plus 3c equals 0, this is the third. Another one is 2b plus 3d equals, in this side there is 1, this is the fourth. So all of these ones are what we call the equations which we have come out with. And we need to find out those unknowns. We need to find out the value of A, we need to find out the value of B, we need to find out the value of C and the value of D. So for this case, we are going to be solving equations which are similar. You can say now, solving 1 and 3 simultaneously, we are choosing the equations which are the same. So equation is having A plus C equals 0, and another one is 2A plus 3c equals 0. So can we try to eliminate a? We are going to put a 2 up, then a 1 down. So can we multiply throughout? Then at the end, we try to collect the like terms. 2 times a, we get 2a plus 2c equals 0. Then you have got 2a plus 3c equals 0. How can I make a to go? We subtract. A 2a minus 2a, we are getting a 0. 2c minus that, we are getting minus c equals 0. Divide out by -1, we are going to remain with c equals 0. So after coming out with the value of c equals 0, we are free to substitute in any equation to obtain the value of a. We can say put c equals 0 in 1. Equation 1 was saying a plus c equals 0, for which our c is already 0 equals 0. It means a equals 0. We have finished getting the values of that. Now, after solving 1 and c, because we were having the same coefficients, now we are having the same unknowns, we also got to look for those numbers which have also got the same unknowns. You can see 2 and 4. So we shall say solving 2 and 4 simultaneously. Solving 2 and 4 simultaneously. So what is equation 2 having? Equation 2 is having b plus d equals 0, and equation 4 is having 2b plus 3d equals 1. Can we eliminate? Put a 2 up and a 1 down. So 1 to eliminate b. Multiply out, we are getting 2b plus 2d equals 0. Then we are having 2b plus 3d equals 1. We subtract. 2b minus 2b, it is disappearing. 2d minus 3d, we are getting a negative d 0 minus 1 you're getting negative 1. So d alone equals 1. After coming out with the value of d equals 1, put in any equation to obtain the value of b. You can say put d equals 1 in equation 2. What is equation 2 saying? B plus d was equal to 0. But do we know our d? We have got b plus 1 equals 0. So b alone equals negative 1. So what was the question saying? We said 1 out of x power 4 plus 5x squared plus 6 was the same as we had ax plus b out of x squared plus 3 plus we had cx plus d out of x squared plus 2. Now, can we substitute in those constants which you have got? What was the value of a? A was 0. And 0 plus the value of b is negative 1. So we are going to remain with negative 1 out of x squared plus 3. We come to plus. Do we know the value of c? The value of c is already 0. And 0 times d, we are coming out with 1. So we are having 1 out of x squared plus 2, which is the same as, you can start with the one which is positive. We said it's the same as 1 out of x squared plus 2 minus 1 out of x squared plus 3, which is the same as 1 out of x power 4 plus 5x squared plus 6. So I've finished expressing this number into the required partial fraction.